So yeah, let me use the remaining 15 minutes kind of demonstrating how to use ChatGPT as a virtual tutor. So let me bring up ChatGPT. Earlier today, I got a message I was running out of O1 responses, but it said I'm going to get a new set of O1 coda at 2:15 p.m. So I should have basically unlimited O1 responses. Now, new model GPT 4.5 is now available, but let me just stick with the O1 since that's what I've been using for the purpose of consistency. Let me just stick with the O1. If I see that ChatGPT is struggling with any particular type of question, it has in the past struggled with things that involve geometric reasoning, then I will then I will try ChatGPT 4.5 to see if it does any better. So when you are using ChatGPT as a tutor, this is my caution to you. You first, let me skip the tutorial questions. You have to be, this is just reading check, let me skip it. You have to be careful to not simply ask it a question in its entirety without any instructions. If you do that, ChatGPT won't be all that helpful. Like right now, I didn't give it any instruction. I just copied and pasted in a question. And what I'm hoping to demonstrate with this demo is its bias. ChatGPT is really biased to give you a full and complete answer right away. Because that's frankly what a lot of human testers prefer. People don't like thinking. People don't like being challenged, having to do work. Like we are all lazy in our own way. And really what people prefer is to, get all this right away with a single request. So ChatGPT has been really trained to give you answers that way. So you have to tell ChatGPT that you don't want that because that's how it's been trained. You have to tell it you actually need to struggle, need to work through these questions. So let me tell it. Oops, I meant to first say I'm working through these problems to prepare for a required one-on-one meeting with my instructor, and he will expect me to be able to solve these questions all on my own without any outside help. With all the remaining questions, would you please not give me the answers? First, I'll try to tell you what I've done so far, and I just want you to help as little as possible with the step I'm stuck on. Please help me learn. Oh, capitalize everything. Okay, and it'll respond. Let me find the relatively substantial question in this set, and let me just stick with the problem set 4. Problem set 5 is kind of short. A lot of the questions there are not all that substantial, so let me just stay here, find one substantial question where I can imagine people making some mistakes and kind of work through that with the ChatGPT. So that feels to me like an easy application of the formulas. Also, probably easy application of formulas. Oh, this one. So actually, this looks hard and it can be hard, but in some sense, it's an easy application of formulas. If you follow the hint, go to the section, and I thought I was logged. Yeah, I'm logged in. Why is it asking me about my? Okay. So your textbook derives the formula. Now the derivation itself is complicated, which is why I do it using complex exponentials. But in terms of applying formulas, like this is all you need. Let me see if it's given me. Yeah, I don't know if it hasn't given me permission to use small angle approximation, but you could have just used this formula. Make sure you know how beta is defined up here. Then it should be fairly easy to do. Just one formula, plug in the numbers, you're done. So let me, I only have 2 questions left. Is question 10 any harder? Maybe it is. If you draw pictures, it's not hard. Let me ask ChatGPT. So I'll do it this way. So your textbook has some examples. So you might be looking at that example, but maybe you're not quite applying the example correctly. So the example in your textbook, they call it a double slit diffraction. I think they are using that wording to mean it's a double slit interference, but you now consider the diffraction pattern of the slit size. So your textbook has a figure like this, and let's say you are a bit lost. And is that the only picture? And as you're looking at the picture, you don't quite fully understand how to apply it. So you just think, oh, maybe there should be a 1, 2, 3, 4, 5, five maxima within the central maximum. Maybe. So you put that in, you know how many peaks? 5. That's what was in the textbook. And it says it's wrong. So, and let's say you are stuck. You tried reading it a couple times and you still don't understand. So you now this is this is the kind of scenario where tutor can be helpful. Maybe you are stuck on some weird phrasing that just read wrong to you the first time, and as you are rereading it, you kind of couldn't see another interpretation. So I say, I'm really stuck on this question. See attached. See first attach. I think it's what the textbook calls double slit diffraction, and following the example in the textbook, I put in example into the textbook. See second attached figure. I put in 5 peaks in the central maximum, but the system says that's wrong. Can you help me understand? Let me see what kind of help ChatGPT will give. It might give you advice, helping you think about basically the change in these parameters, width of the slit and the distance. So what's in the textbook, that should be the correct picture for if your slit, this separation is, I think, 3 times? 1, 2, yeah, 3 times the slit width, but here it's 6 times. So you need to work out the relationships again. So here I want to say, is that right? 11 peaks, maybe. Let's see if ChatGPT will walk you through that. Straight lines track where the double slit interference maxima fall relative to the single slit envelope from each slit. Okay, that is good, nice, succinct description in symbols. Okay, single slit envelope. So extends out to the first minima. Yeah, it's describing location here. And that's given by this formula, yeah. And this is the kind of a similar formula that I advise you to kind of watch out for. The single slit diffraction minima look very similar to the double slit interference maxima. You just have to make sure that you correctly understand the argument for derivation so that you don't mix them up. But the bright fringes of the interference, double slit interference maxima, occur here. So you kind of think through at what value of m that maximum is going to fall, where the diffraction minimum will be. To find this, you want all integer m for which, yeah, something like that. Inequality tells you how many bright fringes. Okay, that looks like a step. So let's try working through the numbers. And the ChatGPT didn't give me any help redrawing this figure, which makes sense. ChatGPT can't actually draw any figure, so it won't usually give you help that way. It'll give you help in words and formulas. And I feel like I understand this formula that it has stated because it's basically getting at the angle value here. So let me calculate. Let me do it this way. I'm gonna on the margins write down basically. Wait, why is my on the margins? I'm just gonna write down. All right. So minus lambda over a less than or equal to m lambda over d less than or equal to plus lambda over a. Let me do a bit of simplification. Lambda cancels out. I don't actually have to plug in lambda. I didn't want to do that anyway. So it's 1 over a. Okay. Yeah, I think I can plug in numbers. So plugging in numbers, I would get minus 1 over a, so 1 half. I'm just going to ignore the units. I'll just keep everything in microns. Less than or equal to m is still a symbol, divide by 12, less than or equal to plus 1 over 2. So I'm looking at, so I can have values of m equals 0 will work. That's between here. M equals 1 will work. 1 half is between here. 2 will work. It's between, 1 half. 3 will work between that. And then 4 will work. 5 will work. 6 will work. Okay. Now I'm going to make 2 mistakes. One is counting 6. I'm pretty sure I have to skip counting it. This equality part is, I think, actually wrong. That's one. Two, you gotta count plus and minus. So each of these numbers other than 0 is really 2 peaks. But let me make the mistake and count 1, 2, 3, 4, 5, 6, 7. 7 values of m, else it'll say it's wrong. And ask ChatGPT, why is this wrong? I'll say, does it enter the values m satisfy? Yeah. Yeah, so I think here actually with this, it should have been enough hint that you should consider plus and minus, but let's see if ChatGPT will correct me more specifically. Okay, I found out that lambda will cancel out, and this is how I tried plugging in numbers. I counted the 7 values of m that will work, but the system says that's not right. What did I do wrong? I wonder if it'll correct both the mistakes, or correct the plus minus one first. Because that one is really me not following what it's already said before. Oh, I guess exactly. Yeah. It really shouldn't have the equality portion. It should have said it as inequality, like no equality. Count all integer. 7 in one half plus 7 in the other half. That's also wrong because then you double count to 0. So let's see. It's outer. Oh yeah, outermost would be actually missing. Okay, disappears, so that's good. So we might say, okay, 6 in one half, 6 in the other half. Okay. Um, it's not simply this. Instead, you end up with um, So let's imagine, let's see. So would you, I think if you, did this, so you can do this. Okay, so I didn't count m equals 6. And I counted the other side, so 2 times 6 is equal to 12. It still says it's wrong. So let me write it out. So now count this and this times 2 for m negative, which should have been hint. You shouldn't count m equals 0 again. I think once we get through this part, then the rest should be easier. So we'll wrap this up soon. Still says it's wrong. And it should tell me, oh, don't count 0 twice. It did give me this formula, which if you use it and then, subtract 2, then great. That actually will give you the right answer. But it didn't explicitly tell me that I shouldn't count the 0 in the middle twice. Careful into the count. Okay, we apply canceling both sides. Okay, -6. Yeah. I fully suggest. It's still stuck with it. I already fixed that. Sometimes it does that. But it tells me 11, which is the right answer. And maybe as you read this through, you realize your own mistakes. And I really believe a big part of learning is just, making those mistakes, struggling through. That'll help you remember if nothing else. So let me finish the rest. So if a slit width is doubled, then the diffraction minimum will be narrower. So there will be basically half as many, but with the 0 being in the middle. So is it so there's 5 on either side. Wait, I'm confusing myself now. So if this is 4, the ratio is 3. So 7. I think there should be 5. Okay, good. How many peaks of interference will be if the cell is separated by twice the distance while keeping the width? So I think I'm going back to 2 micron, then double it, then again on either side there will be 5, 5. They're gonna be double now. 10, 10, 20, and then 1 in the middle, so it should be 21, I think. I probably counted it wrong. Well, let me ask a ChatGPT. Thank you. I got A right, and I applied the same reasoning to get B right, but doing the same thing again with the C says it's wrong. And let me just rethink it through. So when you sum twice the distance, then the orders. So you'll go to up to order 12, which will become missing order. So 11. So so I guess it's 11 on either side. So that should be 23, I think. Same up to 12. Yeah. Yeah, I don't think I should have doubled the 5. That's really what it is. I should have doubled the 6 and then subtract 1. If you draw it out like this picture here, you won't miss it that way. So check for missing orders. This off by 1 errors always again. Yeah, and then what will happen if instead of then the count shouldn't change. Overall pattern becomes yeah, overall pattern becomes a shorter wavelength and narrower. To wrap up this, I'll say, all right, I got everything. Thank you. Oh, one thing you can do. I haven't tried this before, so let me see if this will work. So I think you might be able to use ChatGPT the way I'm using it for the lecture comprehension questions. I think you can ask it for another practice question. Let me give that a try. Um, so there aren't really a lot of questions in the problem set, and I think I need more practice to get this right. Can you give me another practice question in this area of a similar difficulty? And I think it should be able to give you a practice question. Let me see. So this area would have been double slit diffraction. I'll see what it does. Yeah, yeah. So I mean, it's a little bit too close, but yeah, it's just more number exercise. Yeah, you can do that. Let me see if ChatGPT can vary it a little bit. Okay. What about other types of questions involving double slit diffraction? In Siena, there are more questions you can think of. I will say the textbook questions are kind of boring in the sense that they're kind of easy for someone to practice and basically memorize the solution steps. Um, not now including screen geometry. Okay, that could be interesting. Let's see. The separation lambda screen placed that far away. Find the angle. Yeah. So it's kind of getting you to instead of memorizing these things involving ratios, now you have to be able to work out the geometry. Yeah. In fact, I think one of the homework questions looked more like this. Might have been last week for double slit interference. Yeah. So yeah. Yeah. So again, this is another suggestion. If you feel like you need more practice, you can do that. But for the purpose of the required one-on-one meeting, I'll stick with the questions you have seen. Unless we are doing it based on your free-form timed assessment, I will stick to the questions you have seen, had a lot of time to think about and solve. So, all right. So let me just wrap this up with the ChatGPT. Thank you. Thank you so much. And then I'll wrap up the session here. Thank you so much to everyone joining, both here in real time or by recorded video. I'm gonna say goodbye to people joining by recorded video, by which I'm gonna stop the recording. And in case people here in real time had any questions, I'll stay online briefly. So bye to people joining by recorded video.